y-intercept. If that is so, the line will be same, but I will look for the y-intercept and the slope. Another point. Now, using what? Slope and y-intercept. Now, first tell me what is the y-intercept of this line?
-5.
-5 because you know from this equation. But if I change that equation, you have to write, you know, that equation in this form. 5x
minus 5 equals
5x
y.
minus 5 equals y, right? And that means what is the y-intercept?
-5.
-5, right? So you plot, first you write in the y equals mx plus b form. And from there, you know this is the y-intercept. You plot that point on the graph paper. Here, write 0, -5. Okay. Okay. Now we have to use the slope. And what is the slope here?
5.
Slope is 5. If slope is 5, that means rise how much, run how much? Rise how much?
Rise is 5,
5,
slope
run
1 is 1.
So rise 5, run 1. Rise 5, run 1 from that point only. So we'll rise 1, 2, 3, 4, 5. Right? And run 1 means 1 unit to the right. So these are the 2 points. So I'll look for 0, -5 and 1, 0. You have to write the coordinate of that point where you end up. Then you connect those 2 points. You see the difference between these two answers. This answer must show 1, 0. Okay, no, there is no difference here because it end up here because the slope was. But what I meant is here you need. It may not end up here. In some other problems, it may end up some other points, you know. So it may not be on the x-axis. It can end up here. In that case, that would be the point. Here, in this case, this is a bad choice of problem. But my point is that your approach would be different. Here, the approach is to find x-intercept, y-intercept, plot those 2 points. Here, the approach is first find out the y-intercept, then you go from there using the slope